Hello everyone, I'm Preetika. Now I'm going to give a brief explanation about design principles. Design principles. There are certain design concepts and principles that govern the building of quality software design. Some of the common concepts of software design are abstraction, information hiding, functional decomposition, design strategies, modularity, and modular design. Abstraction. The process of describing a problem at higher level of representation without bothering about its internal details. Problem partitioning and abstraction are closely related in software design. In this abstraction, there are two levels of abstraction: high level abstraction, low level abstraction. There are three types of abstraction, namely functional abstraction, data, and control abstraction. ADT such as structures in C, classes in C++, and packages in Java are the examples of data abstraction. A more detailed example for the ADT of the stack in C++ is as follows. Control provides the operational characteristics of the system without describing their implementation details. For example, loops, iteration, frameworks, multithreading, and describe control abstraction. Advantages of abstraction. It reduces the complexity of modern computer programming for software users and engineers. It helps in program organization that can be generalized for recovering common problems, and therefore it promotes software reuse. It separates design from implementation, which is easy to understand and manage. Information hiding. Information hiding is the important design principle, which is expressed through encapsulation and abstraction. It helps in modularization of software projects into small components. It allows the programmers to change the implementation of the application for better performance. Functional decomposition. Functional decomposition is the process of partitioning a large and complex problem into small, manageable, and understandable pieces. It is performed using abstraction information hiding. The decomposition process uses divide and conquer approach to divide the software into independent parts. Decomposition is performed into different manners in different design methodologies. For example, structure, object-oriented, component-based development. The decomposed parts are organized into hierarchy in components. Functional decomposition. Functional decomposition of WordPad. WordPad. In this WordPad, we can create the file. We can save, edit, printing, formatting, setting. In saving, we have two options: save as, saving, formatting, color, font, tab, and paragraph. Design strategies. Top-down strategy. A top-down strategy is also referred as stepwise refinement. Is essentially partitioning a system into elaborate on the subsystems. It starts with a global view defined at a high level of abstraction of the overall system. The system is defined and decomposed into next lower level subsystem. Each subsystem is again decomposed into specific level of detail to identify a concrete level of subsystem. The process of elaboration is continued until we reach the concrete level of detail. At this level, design decisions are taken easily and subsystems can easily be developed and managed. It is the main problem in top-down strategy. Bottom-up strategy. A bottom-up strategy, also referred to as layers of abstraction, is piecing together in the subsystems to form a whole system. It starts with the lower level subsystems at the bottom level. That is, the individual elements in the system. The system are then combined together to form upper level of abstraction, that is subsystem. In turn, subsystems are again put together to design the next level of the subsystem. The process of layering the abstraction levels is continued until the top level of the system is reached. Each level of abstraction performs services to its upper level of the system. It is the bottom-up strategy. Modularity. Modularization is the process of breaking a system into pieces called modules so that this can be easily managed and implemented. A module is a part of software system that can be separately implemented, and a change in module has minimal effect on their modules. Module can be a function, procedure, program, subroutine, class, package, framework, library files, templates, and components, etc. A modular system consists of various modules linked via interfaces. An interface is a kind of link or relationship that combines two or more modules together. Modularity is a measurement of modularization of the system into pieces. A module has the following characteristics. Modularity enhances quality factors such as portability, compatibility, extensibility, and scalability. A module contains data structures, instructions, input-output statements, processing logic. A module can also be called into another module. Modularity also abstraction, which helps in defining a subsystem. Modularity improves design clarity and understandability. Coupling. It is the strength of interconnection between modules. It is a measure of degree of interdependency between modules. Modules are either loosely coupled or strongly coupled. The strength of interconnection between modules is influenced by the level of complexity of the interfaces, type of connection, type of communication. In this coupling, there are types: message, data, control, stamp, common, external, content coupling. It's highest to lowest, worst to best. Cohesion. Cohesion of a single module is the degree to which the elements of a single module are functionally related to achieve an objective. Module cohesion represents how tightly bound the interval elements of the module are to one another. A functionally independent module has a higher cohesion as compared to dependent. In this, there are levels of cohesion: functional, sequential, communication, temporal, procedural, logical, coincidental cohesion. And thank you.